Morning, everyone. Yesterday we were discussing about the rate of reaction, types of rate of reaction. Already we discussed about average rate of reaction. What is the meaning of average rate of reaction? The rate of reaction which will be calculated in a time interval is calling as a average rate of reaction. Now we are discussing about the instantaneous rate of reaction. What is the meaning of instantaneous? In that name only answer is there. It is nothing but rate of reaction which is calculated at a particular time is also calling as at a particular instant or at that instant. Did you got what is telling? The rate of reaction which is calculated at that particular time, not in between two different times. At that particular time, what is the speed will be there? That is calling as instantaneous rate of reaction. We can understand by taking one example. Take a chemical reaction, reactants are converting into products. Okay, initially means what? Time t is equals to 0. At a time t is equals to 0, for example, I am taking 5 molar of reactant. Is there any chance to get product? No. Why? The reaction not yet started. Okay, after 2 minutes I observe. What changes will come? Concentration of reactants is decreasing and products will be increasing because reactants is consuming and products will be forming. So what I observed, for example, here I observed 3 moles and here 2 moles. Now after some time I observed again some changes at 5 minutes time. Still what happening? Reactant concentration will be decreasing, products will be increasing. For example, I observed here 2, here 3. Any problem? No. What is the average in between 2 minutes and 5 minutes? What is the average speed? That is calling as average rate of reaction. Now we are not doing average. What we are doing at a particular time means at a 2 minutes time, for example, whatever speed of the reaction will be there, that is only we are calling as instantaneous rate of reaction. At a particular time, at that spot, what is the speed of the reaction? It is calling as instantaneous rate of reaction. Is it possible to calculate from this information? No. Why? At that instant, what is the concentration of the reactant and product? We can't identify. That's why compulsory we have to use the graphical method. All of you getting it? So, how can you represent the instantaneous rate of reaction? Means is nothing but with respect to reactant means we have to write down negative. Okay, instantaneous, no, we have to show some difference here is nothing but small d, change in concentration of reactant by time change. Or also nothing but with respect to product which what can be written? Change in concentration of the product by time change. To show the variation, instead average rate is denoted by writing a capital. That's it. The process will be remains same. First of all, how we will get the information from the graphs I want to discuss. You see carefully graphs. Okay, first of all, I am floating the graph between concentration of the reactant versus time. Okay, you know very well, take 2 axes. On this x-axis I am taking time values. On y-axis I am taking concentration of the reactants. What happened? As the time is going on, what happening? Concentration of the reactant will be decreasing. At 0 time, higher value. At 5 minutes, decreasing. That's why the graph will be coming like this. Are you agreeing or no? Yes. Now this is the graph for concentration of reactant versus time. Okay, this is the 0 minutes time, and this is 1, and this is 2, 3, 4, 5, like that will be. At what time you want to find out the speed? At 2 minutes. Yes. At that 2 minutes, we have to draw one vertical line to that curve. Okay, it is intersecting this point. Observe very carefully. At that point, you have to draw one tangent line to that curve. Means it is nothing but tangent line for this one. This is calling as tangent. Are you clear? Yes. How it is able to get the instantaneous rate of reaction? I will explain. Later we have to take one line to the parallel to the x-axis, one line or one line to parallel to the y-axis. Then we are getting one right angle triangle. We are getting. Did you observe or no? This is A. This intersecting point. This intersecting point is B. This intersecting point is C. Separate the right angle triangle. It is nothing but like this will be there. Okay, this is A, this is nothing but B, this is C, this is nothing but tangent line. Where angle will be 90? At B, angle will be 90. Okay, after that at the C, we are getting some angle that is denoted by theta. Okay, now I want to find out the slope of this tangent. Slope of tangent. I think you know in mathematics, the slope of straight line is nothing but denoted by tan theta. What is the tan theta formula? Opposite edge length by hypotenuse. Is nothing but what the opposite edge AB by what is the hypotenuse is nothing but AC. Okay, indirectly AB indicates which differentiation? Change in concentration of reactant. What is the basic differentiation is nothing but indicates time change. Indirectly it is nothing but which one? Change in concentration of reactant by time change. Okay, if you see this one, we are getting tan theta value should be coming negative value is nothing but the change in concentration of reactant by time change at that spot. Okay, but we know rate of instantaneous reaction. Rate of instantaneous reaction in terms of reactant minus of change in concentration of reactant by time change. From Prof you got that value is negative. Negative of negative is becoming a positive value. So if we can substitute here minus of minus value, finally we are getting which value? Positive value. It is 100% correct. Why? Because rate is nothing but speed is always should be positive. Did you got my point or no? Yes, we have to take like this. Same concept we are explaining with respect to products. You see that. Second information. I want to float a graph between concentration of the product versus time. Okay, first of all, you see this one right over here separately clearly. Okay, this is the time axis, is nothing but x-axis. On the y-axis, I am taking concentration of the products. What changes is coming? Initially, concentration of the product is 0. At a time 0, this is 0. As the time is going on, increasing. That's why the graph is started 0 point and going like this. Okay, now this is the time 0. After that 1 and 2, 3, 4 minutes, 5 minutes like that. At which time you want to find out the speed of the reaction? 2 minutes. So at which time you want to find out, there you have to draw one vertical line to that graph or curve. Okay, we are getting one intercepting point you are getting. At that intercepting point, how to draw one tangent line? How to draw? This is nothing but a tangent line. Later procedure, you have to take one axis to x-axis, and you have to take one line to which axis? Y-axis. Then you are getting one of the right angle triangle. You are getting that is nothing but A, B, C. I am separating that one. You see carefully. That is nothing but right angle triangle A, B, C. Okay, where angle here? Angle will be theta, but here angle will be 90. Okay, later process is common. If you take this one, I want to find out the which one? Slope of tangent. Slope of tangent is nothing but tan theta. Tan theta is equal to formula opposite by hypotenuse. Is nothing but AB by what is coming? AC. What is the meaning of AB? This length or this difference is nothing but change in concentration of the product by AC. AC means this difference indicates time change. Okay, but here we are getting tan theta value will be coming, positive value is nothing but change in concentration of product by time change. In terms of product, what is the formula for R instantaneous? Same. It's nothing but R INS or instantaneous is equals to change in concentration of product by time change. Whatever change in concentration of time or means product to time, that value will be coming from graph that to from slope of the tangent. So like that we can calculate the speed of the reaction at any particular time, that is calling as instantaneous. No, we are calculating the speed of the reaction in between 2 points, that is calling as average rate of reaction. All of you got it? Yes. Okay. Now we are discussing some important information. It is nothing but factors effects on rate of reaction. This is important concept. Now you have to understand very carefully now onwards. What are the factors effects on rate of reaction? Means what are the factors will influence the speed of the reaction? We know very well. Tell me. So first point is nothing but the concentration of reactants. Concentration of reactants. Yes or no? Yes, I will explain everything. We will discuss very briefly every factor. Second one, it is nothing but partial pressures of reactant when they taken in gas phase. And we have to see some other things is nothing but nature of reactants. And later we have to see some other things is nothing but fourth factor, very important, it is nothing but temperature. Temperature is also will influence the speed of the reaction. And another factor is nothing but a catalyst. Yes, the speed of the reaction will be also changed by using catalyst. These four factors will influence the speed of the reaction. Now we are discussing one by one very briefly. First of all, I want to explain the effect of which one? Concentration. Concentration effect on rate of reaction is asking this question only as a true mass answer. Okay, what is the effect of concentration on rate of reaction is also calling with several names. Rate law. It is also calling as rate expression. And also calling as rate equation. He will ask as it is in the board examination, explain the rate law or what is the rate law. Indirectly, it will tell us about the effect of the concentration on the speed of the reaction. Okay. Now we have to discuss. First of all, I will take one of the chemical reaction. X moles of A and Y moles of B is converting into some moles of the product. What the reading of this one? A and B are reactant. The coefficient represents its moles. X moles of A combining with Y moles of B converting into products. Okay, but according to law of mass action, what law of mass action is telling? In every chemical reaction, rate of reaction is directly proportional to the concentration of the reactants. We studied already the chemical equilibrium. Yesterday also we discussed this one. Then write down R is directly proportional to concentration of A. While writing like this, what happening? Coefficient will come as it is in its powers into concentration of B power Y. Otherwise, we can write here, according to law of mass action, rate of reaction is directly proportional to concentration of the reactant. That's what we are writing here. Okay, still I want to simplify. I want to remove the proportionality. Then I have to multiply it with one constant, concentration A power X into B power Y. This is calling as theoretical equation. Okay, but experimental equation, how it is changing? I will write here. R is equals to K into A power M and B power N. This is calling as experimental equation or experimental rate equation. I will explain everything. You have to observe very carefully. This experimental rate equation only we are calling as rate law or rate equation or rate expression. Condition here, in the experimental rate equation, whatever powers is coming on reactants, they may or may not be equal with what is this X and Y? Coefficients of A and B. Means that is the point only. In the experimental rate equation, whatever powers of the reactant will be there may be M and N may or may not be equal with which one? X and Y. What is the meaning of X and Y? Coefficients of the reactants. They may come as it is in its powers or no. Means some changes will be coming. The resultant equation only we are calling as experimental rate equation. That is only we are calling as rate law or rate expression or rate equation. But see, you see very carefully this information. Okay, you are taking one of the common reaction with the different modes of the reactant. Okay, according to law of mass action, every chemical reaction, rate of reaction is directly proportional to concentration of the reactant, 100%. Okay, you apply this one and you are taking some concept. This is just a theoretical equation. But after doing experiment, what is coming? Some M and N is coming as its powers. What is the condition here? The powers of the reactants may or may not be equal with the coefficients of the reactants in the balanced equation. That is only calling as rate law. Okay, I will tell the rate law once again. You see, in the experimental rate equation, the rate of reaction is directly proportional to the concentration of the reactants. In that, powers of the reactants may or may not be equal with the coefficients of the reactants in the stoichiometric equation or balanced chemical reaction. Once again, in the experimental rate equation, rate of reaction is directly proportional to concentration of the reactants. In that, powers of the reactants may or may not be equal with the coefficients of the reactants in the balanced chemical equation. If you write like that, you are getting 2 marks. Okay, when they become equal, when they may not be equal, we will discuss one by one, everything very clearly. Okay, you take that rate equation or rate expression. It's nothing but R is equals to K into concentration of A power N and B power A. Okay, here K is calling with the different names. K is calling as a rate constant. K is calling as a rate constant, or also calling with the different names velocity constant. Why? Because it is nothing but the speed, so its constant is calling as a velocity constant. In some high standard exams, he is asking also like a specific reaction rate. Specific reaction rate, whatever it is, meaning will be same. He given K value. K is calling as a rate constant or velocity constant, or also calling as a specific reaction rate. Okay, based on this one, I want to see some important information. So define rate constant value. Is it possible from this? Yes. When? So whenever concentration of A is equals to 1 molar, whenever concentration of B is also equals to 1 molar, indirectly we can write concentration of the reactant is equals to 1. Substitute in the rate equation, R is equals to K into concentration of A power M and B power N. Whatever powers is not a matter, 1 power anything, 1. So then what happening here? 1 into 1, 1, then it is nothing but R is equals to K. Can we define the rate constant? Rate constant is defined as rate of the reaction when concentration of the all reactant should be equals to 1 molar. Once again, rate constant is defined as rate of reaction when a reactant's concentration should be 1 molar. Okay, still I want to discuss some other important information regarding K value. K value is helpful to us very lot. Okay, from this can we tell one important relation between R and K? If they are a constant, then what happening? R is directly proportional to K. R is directly proportional to K means what? For any reaction, K value will be high. Speed of the reaction is also high. So means from the K value we can measure the speed of the reaction, or we can compare the speed of the reaction. For example, for one reaction, we given K is equals to 10 to the power of 5. For another reaction, K2 is equals to given as 10 to the power of 2. Out of two reactions, which reaction will be high speed? We can easily tell. Why? Because this is a higher K value, that's why this is related to first reaction, that reaction speed will be high. From this we can get it. So next one more point, very important, the K value. The K value is only depends on temperature. Why? While calculating K value, is there any concentration terms? No, we are taking them as a unity. That's why the rate constant value will not be affected with the change in concentration. Is only depends on which values? Temperature changes. That is a very important concept, and that concept we are discussing under temperature effect. So the rate of reaction is directly proportional to rate constant. If rate constant value is high, the speed of the reaction is also high. The rate constant value only depends upon temperature changes. So what is the data? In the experimental rate equation, the rate of reaction is directly proportional to concentration of the reactant. In that, powers of the reactant may or may not be equal with the coefficients of reactants in the balanced equation. When equal, when it will not equal, we will discuss. All of it clear? Okay, now we will discuss in rate equation when powers is equal to coefficient, when it will not be equal, we will discuss. Under that first case, I am telling M and N is equal with the X and Y. What do you mean? Powers is equal to coefficient. Means coefficient will come as it is in itself. Powers while writing the rate equation in case of elementary reaction. Elementary reaction. Anybody, what is the meaning of elementary reaction? This is fixed. In all elementary reaction, the coefficients of the reactant will come as it is in its powers while writing the rate equation. What is the elementary reaction? Elementary reaction means is nothing but a reaction which takes place in a single step. Which takes place in a single step. Means just reactants is combined together and converting into products. Such reactions is called as an elementary reaction, and definitely powers is equals to coefficient. Just I will give you some example for this one. First one I am writing ammonium nitrite. Ammonium nitrite will be converting how anybody N2 plus 2H2. I am telling it is the elementary reaction. No other steps. Directly it will be converting into products. Then what will happen is that rate equation write down R is equals to K into concentration of reactant means what amount? Ammonium nitrate. What I told, the coefficient will come as it is in its powers. No option for that. Can I give one more elementary reaction example? H2 plus I2 is gives rise to 2HN. I mentioned in the exam also he will mention whether it is complex reaction or elementary reaction. He mentioned it is the elementary reaction. Immediately what happening? Rate R is equals to K into concentration of H2. What will come on? Coefficient will come as it is in its powers. I2 coefficient is how much amount? 1. Right on its powers. Means M and N is equal with X and Y. Okay, can I give one more example? For example, if you take one more thing like 2NO, very good. If you can take 2NO plus O2 gives rise to 2NO. In this also rate will come like R is equals to K into concentration of NO square and concentration of O2 power 1. The coefficient will come as it is in its powers. Is calling as an elementary reaction information. Now, when it may equal or may not be equal, second case, M and N may or may not equal with which one? X and Y. Powers is may or may not be equal with coefficients in the equation. That is calling as a complex reaction. It is possible in case of complex reaction. Complex means what? Not single step. It is a chemical reaction which takes place which takes place more than one step. More than one step. Such reactions is calling as a which reactions? Complex reaction. In this case, may equal or may not be equal. 90% is not equal. Why? Because it is already equal in case of element reaction, but in few cases there also will be equal. We will discuss that. So what does it mean? The powers of the reactants may or may not be equal with the coefficients like x and y in case of complex reaction. Complex reaction is what? The reaction which will be takes place by taking more than one step. Okay, just I will give you one example. H2O2 decomposition. What happened everybody? We are getting 2H2O plus O2 we are getting. I only telling this is the complex reaction. Complex reaction is proceeding by taking more than one step. How? First of all, I am telling that first step. How is this one? H2O2 is decomposing like first water and special oxygen. Did you know this oxygen? How you will call this special oxygen is calling as a nascent oxygen. What is the meaning of nascent oxygen? It is not an atom, it is not a molecule. It is a powerful oxygen atom. Powerful oxygen atom means nothing but highly reactive. Highly reactive. Highly reactive means nothing but unstable particle. It won't exist. Again, it will be consumed in the reaction. Okay, let it be. Now comes to second case. Out of two, one is already consumed, one more H2O2 is there. Yes or no? Yes. It will be takes that nascent oxygen atom, more powerful than atoms. Then what we are getting anybody? H2O2 is decomposing like H2O and one